Okay, let's dive right into this. Welcome to today's Explainer. We're tackling a massive, globally impactful climate event today, El Niño. Now, if you follow climate news at all, you hear this term literally all the time. But today we're going to look at a brilliantly simple framework that unpacks exactly how this whole planetary mechanism works. And we're going to do it without getting completely bogged down in all the usual jargon. So to get started, I actually want you to run a quick little thought experiment with me. It's incredibly simple. Just imagine you're sitting in a bathtub. The water is perfectly still. Now you lean forward and you start blowing air right across the surface of the water, from one side of the tub to the other. Naturally, the wind from your breath pushes that water, and it starts to pile up at the far end of the tub, right? Well, here is the absolutely crucial question. Imagine you suddenly just stop blowing. What happens?
Exactly. The water sloshes back. That piled up water doesn't just, magically stay there without the force of your breath holding it in place. It inevitably flows right back to level things out. And it turns out that really simple physical reaction, water sloshing back when the wind stops, is actually the perfect way to visualize what happens on a massive, massive scale in the Pacific Ocean.
Moving into part 1, the normal Pacific. So, to map our bathtub analogy onto the real world, we first have to look at the Earth's version of you blowing across that bathwater, and that is the strong trade winds. On a normal day, these powerful trade winds blow really consistently from east to west across the Pacific. Think of them as a giant planetary fan. They're just constantly pushing all that warm, sun-heated surface water toward the western side of the ocean, piling it all up near Indonesia and Australia.
But if all that warm surface water is constantly being pushed away from the eastern side of the Pacific, over near South America, specifically Peru and Ecuador, well, what replaces it? The answer is a really vital scientific process called upwelling. See, because the warm water gets pushed out west, incredibly cold water gets drawn right up from the deep ocean to fill that void.
Now, what's really fascinating here, and honestly super important, is why that cold water matters so much. This isn't just a slight temperature drop, it's literally an engine of life. That deep ocean water rising up is absolutely packed with essential nutrients. When those nutrients finally hit the surface, they act like a powerful fertilizer, creating this incredibly rich marine ecosystem. In fact, this upwelling is the exact reason why the coast of Peru is one of the most productive, top-tier fishing regions on Earth. It sustains massive fish populations and, for sure, the local coastal economies that completely rely on them.
Which brings us to part 2. When the fan stops.
Imagine someone suddenly walks over and just turns down that giant atmospheric fan. During an El Niño event, those strong trade winds we just talked about unexpectedly become weaker. The fan gets turned down, and suddenly, those winds are no longer strong enough to hold back the ocean. So exactly like our bathtub, that massive pile of warm water that had been sitting over near Indonesia just starts flowing back. It sloshes eastward, spreading right back across the central Pacific towards South America.
And the immediate local consequences of this sloshing? Well, they're pretty devastating for marine life. As that warm water spreads back into the east, it just sits on the surface and acts like a thick cap. That cold water upwelling we talked about becomes much, much weaker. Suddenly, far fewer nutrients are reaching the surface. And without those nutrients, the bottom of the food chain basically collapses, and fish populations rapidly decline because, well, they simply don't have enough to eat.
Part 3. Moving the giant heater.
So we've looked at the water, but to really understand why El Niño is a global event, we have to shift our focus from the ocean up into the sky. Like, why does a shift in ocean water so drastically alter the weather? It's because the ocean and the atmosphere are in this constant conversation, always exchanging heat. Step 1, the warm water moves east. Step 2, that warm water vigorously heats the air right above it. Warm air rises, and as it does, it forms massive clouds and rain. So, step 3, when that warm water moves east across the Pacific, it takes the rain and the storms right along with it. You're effectively dragging a giant planetary heater across the Pacific Ocean. And the atmosphere? Well, it has absolutely no choice but to respond.
Moving on to part 4, global ripple effects.
This shifting heater doesn't just change things out in the middle of the ocean, it completely impacts land masses and human lives worldwide. Because this massive system of rainfall completely shifts its location, we start seeing dramatic, highly contrasting weather extremes triggered all over the globe. On the eastern side, Peru and Ecuador are suddenly just hammered with heavy, relentless rain and flooding. Meanwhile, over in the west, places like Australia and Indonesia are robbed of their usual rainfall, leaving them facing severe droughts and some really devastating wildfires. Worldwide agriculture can be heavily disrupted by these sudden shifts in precipitation, and as we already saw, marine ecosystems suffer deeply. It's just a massive global chain reaction. So the really crucial point here is that a change in the Pacific definitely does not stay in the Pacific. Scientists actually have a specific term for this global ripple effect: teleconnections. These are atmospheric connections that act almost like invisible wires in the sky, transmitting all these changes in the Pacific Ocean's weather patterns to completely distant corners of the globe, far, far beyond the ocean itself.
Which brings us to part 5. Why exactly is it called El Niño? The origin of the name is actually a really fascinating piece of history. Long before we had satellite tracking or complex global climate models, Peruvian fishermen were out on the water literally feeling these changes firsthand. They noticed that every so often, the waters off their coast would become unusually warm, and this almost always seemed to happen right around Christmas time. Because of that timing, they started calling this warm water event El Niño, which is Spanish for the boy child, making a direct reference to the Christ child. Decades later, when scientists finally pieced together the mechanics of this whole massive climate phenomenon, they respectfully adopted the fishermen's nickname for it.
And that brings us to our final thought. The big idea here is honestly beautifully simple, yet entirely planetary in scale. Normal years have a strong fan pushing water west, feeding life in the east. El Niño years see that fan weaken, the water sloshes east, and the world's weather goes totally haywire. So I'll leave you with this. The next time you experience an unusual stretch of heavy rain or an unexpectedly harsh dry spell, take a moment to look up at the sky and ask yourself, is the Pacific bathtub sloshing? Thanks for joining me for this explainer. I hope this fundamentally changes how you view our incredibly interconnected world.